Okay, so today we are going to continue with 6.3 permutations of n different objects taken R at a time. Okay, so the number of permutations of n different objects taken R at a time is given by n PR. So it is equals to n factorial over n minus R factorial. So a permutation of n different objects taken R at a time is an arrangement, okay, arrangement of a set of R objects chosen from n objects. So the order of the objects is chosen in the chosen set is taken into consideration. So in permutation, we need to know the order so that we know how to do the permutation. So the number of permutations of n different objects, okay, taken all at a time is npn. Okay, this one is for all at a time. So n factorial over n minus n factorial. So n factorial over 0 factorial. So n factorial over 1. So the answer will be n factorial. This is all at a time. But what if we need to do arrangement? Okay, let's see. Calculate 7 permutation 2. Means in 7 items, we choose 2 and we need to make them in arrange in an arrangement. So 7 factorial over 7 minus 2 factorial. So it's 7 factorial divided by 5 factorial. 7 factorial equals to 7 times 6 times 5 factorial. So 5 factorial and 5 factorial will be eliminated. So we're left with 7 times 6. So equals to 42. Or we can just use calculator. Okay, so just use 7 shift NPR 2 equals to 42. Okay, so calculate the number of 3-digit numbers that can be formed using the digits 2, 4, 6, 8, 9 without repetition. Okay, so we have 2 methods. Okay, one method is multiplication principle. So we have 2, 4, 6, 8, 9, right? Okay, so how many hundreds we can use? How many numbers we can use to put in hundreds? We have 5 numbers. How many numbers we can put in 10? Okay, 4 numbers. Why? Because you have used 1 number to put into hundreds. So you're left with 4 numbers. And then you use another 1 number, okay, to put in 10. Then you're left with 3 numbers in ones. So the place of hundreds can be filled in 5 ways. 10 can be filled in 4 ways. 1 can be filled in 3 ways. So the number of 3-digit number can be formed is 5 times 4 times 3. The answer is 60. How about if you use method 2, permutation? The number of 3-digit numbers can be taken by arranging 3 digits taken from 5 digits. So it's 5p3. So the answer should be 60. Okay. Okay, this is a clone exam watch. Okay, so we have how many digits? We have 5 digits, right? Without repetition, okay, we need to calculate the number of 4 digits number. So from 5 digits, we need to take 4 digits. So it's 5p4 equals to 120. How about this one? In 5 digits, we need to make them greater than 5,000. 4-digit number greater than 5,000. So in the case of 4-digit number, they are greater than 5,000, we can have possible arrangement as follow. We can have 5,000 plus plus plus. We can have 6,000 plus plus plus. We can have 7,000 plus plus plus. Okay, if we put 5, 6, 7 as the first number, so we are left with 3 numbers in the back, right? We're left with 3 numbers at the back. So that means in 5, if you put 5, 6, 7, so in between the 5 numbers, right, we are left with 4 numbers. But you can only, in the 4 numbers, you can only choose 3 numbers to put behind 5. So it's 4p3. Same goes with 6 and 7. So we have 3 sets of 4p3. So if we have 3 sets of 4p3, So hence the number of 4-digit numbers that are greater than 5,000 can be formed is 3 sets of 4p3. So the answer is 72. Okay. How about the number of 4 digits odd numbers less than 5,000? So less than 5,000, we can put 3 and 4 in front, right? We can put 3 and 4 in front. But if we put 3, then we only have 5 and 7 to make the number as odd number. If we put 4, we have 3 numbers that can make the whole number become odd number. So the first digit has to be less than 5. At the same time, the last digit has to be odd number. So the number of ways to arrange digit 467 into 2 empty space, okay, for the first one, we only have left with 467, right? Since 3 and 5 is put at the first and the last. Now we're left with 467. So the space given only 2. So it means it will be 3p2. In the second one, it's only 456. So we have 3 numbers, but we only have 2 spaces. So 3p2. Okay, same goes with here. So 5 sets of 3p2. If we have 5 sets of 3p2, so it's 3p2 times 5. So the answer is 6 times 5 equals to 30. Okay, you must remember that repetition of digits are disallowed. Okay, based on the question. So for this one, a male teacher, 3 male students and 3 female students are to be seated in a row for a photograph to be taken. Calculate the number of ways they can be seated if A, the teacher is to be seated at either end. Okay, so let T become teacher, M become male student, F become female student. So our first case, teacher sitting at the left end. So we have 1, 2, 3, 4, 5, 6. Okay, so the number of ways to arrange 3 males and 3 females, okay, is 6 factorial. Okay, if we put again the teacher sitting at the right end, the students sebarang you arrange at the front here, also 3 male students and 3 female students. So it's still 6 factorial. So now we have 2 sets of 6 factorial. So it's 1, 4, 4, 0. B, the males and females are to be seated alternately. So if the teacher is a male, right? Okay, so T, F, M, F, M, F, M. So the number of ways to arrange the males is 4 factorial. The number of ways to arrange the females is 3 factorial. So if you use multiplication principle, so it's 4 factorial times 3 factorial. So we have 1, 4, 4. Okay, because the teacher is male teacher written here, so that's why arrangement should be T, F, M, F, M, F, M. Okay. Lastly, okay, so the diagram below shows 5 cards of different letters. Okay, so L or GIN. So calculate the number of arrangement in a row of all the cards. So number of arrangement, you just use 5 factorial because you don't need to choose any few cards in between all the 5 numbers, so you don't have to use permutation. B, calculate the number of this arrangement which the letter OI are side by side. Okay, means the OI has to be together. LGN sebarang you put. So if the OI is side by side, then they will be considered as one item. So together with letter LGN, they are all together 4 items. So like this. So the number of arrangement is 4 factorial. Okay. But the letter O and I can also be arranged among themselves in their group. Okay, so number of arrangement is 2 factorial. Do you understand what step 2 means? Means O and I doesn't have to be OI. It can also be IO. Okay, it can also be IO. Okay, so the multiplication principle should be applied. So 4 factorial times 2 factorial. So it's 224 times 2. The answer is 48. Okay. So this will be your homework for today, 6.3, and also this one.